So, basic quick overview, we split from our most recent living common ancestor, chimpanzees, about 7 million years ago. And through that time period till now, there are about 15 to 20 different species of hominids that are widely recognized. So I'm going to be quickly going over those. So forgive me if I like butcher their names because I'm not good with names. So the first was Lentoshithensis. They evolved 76 million years ago in West Central Africa. Their brain size were smaller than chimpanzees, but they had a lot of similar features like sloping faces, elongated skulls, and a lot of prominent brows. But at the same time, they had differences like smaller canines, and the middle part of their face were smaller, and the foramen magnum, which is where the skull and where the spinal cord exits the skull, is more underneath the skull. Like as you see in the apes here on the left side of the image, it's more at the back of the skull. When humans is more towards the bottom, which is signaling that they start having more bipedal movement. So they're at least on two legs by now. So then the Ornithogenensis lived in eastern Africa about 6.2 to 5.8 million years ago. They're the size of chimpanzees, and they had a lot of they're still a lot very similar to chimpanzees. They had smaller teeth though with thicker enamel, and the upper femur bone had a buildup, like it was starting to get stronger. They said that too they had bipedal movement because when you walk, you put all when you walk in bipedal movement, you put all your weight on one foot, so then you have to really build up those bones, so you're able to walk efficiently. The next species, Ardipithecus caraba, it lived about 5.8 to 5.2 million years ago in eastern Africa. They were bipedal, but their bodies and brains were still very similar to chimpanzees, but their canines were resembling those of later hominins. There were many other fossil teeth fossils, but there was this one big toe fossil that is very significant as a big toe fossil because when we walk, we put our whole heel down, we go into our toes, then we push off the ball and our heel for the ball and the toe when we walk to lift up our foot. So it's showing that they're getting more and more bipedal. Next one's Ardipithecus hermidus. They were alive about around 4.4 million years ago in eastern Africa. They also had this large toe and they had a more rigid foot. And their pelvis were showing adaptation for tree climbing and bipedal movement. But one thing I found significant about this that in the same layer that the species was found, same layer of rock, there are fauna remains for wooded environment. So this kind of goes against the open savanna theory, which states that because of climate change, like we were originally living in trees, then it started to turn more like a savanna type land. So then we had to go and like we had to start standing on two legs so we could like see more predators. So it kind of was a little bit against that. So I found that kind of interesting. Next species, Australopithecus anamensis. It lived 4.2 to 3.8 million years ago in, in eastern Africa. Their shin bone and ankle joints were similar to humans, but their arms were still more similar to chimpanzees, showing that they climbed on trees still. And they still had like the facial features were still more similar to that of chimpanzees. Then the Australopithecus afarensis, who lived from 3.85 to 2.95 million years ago. This is where the famous Lucy is. They were in eastern Africa, and there were over 300 remains found of the species, and they survived for 4 times as long as we have. Next species, the Kenanthropus platyops, was alive at 3.5 million years ago in eastern Africa. They had a flat face and small brain, so this flat face feature actually didn't come back until about 2 million years ago. Next species, the Australopithecus africanus. They lived from 3.3 to 2.1 million years ago in southern Africa. They had rounder skulls than the Australopithecus afarensis, which is where Lucy was in, and they had smaller teeth. But they still had the arms and the sloping face that are more similar to chimpanzees, showing that they're still climbing, but they still also had bipedal movement. Next species, the Paranthropus aethiopicus, lived 2.7 to 2.3 million years ago in eastern Africa. There weren't many remains, but we still saw they had that slanted face. They started having larger teeth and more powerful jaws, which helped them with more their vegetarian diet. The next species was Australopithecus gari, which lived about 2.5 million years ago in eastern Africa. There weren't actually much remains found of this exact species, so there's like one cranium for the skull fragment. So bones that are found in a similar layer were used to kind of define the species. Not much is really known about it. Next species, the Homo habilis. We finally found the Homo genus. It was 2.4 to 1.4 million years ago in eastern and southern Africa. They had larger brain cases and smaller face and teeth, and they were the first hominids to use stone tools. So they started to use tools to actually make their life easier. They started using stone to help them in hunting. Okay, the next species is Paranthropus boise. They lived from 2.3 to 2.1 million years ago in eastern Africa. They were characterized by more heavy chewing, and they had a stronger sagittal crest, which were the muscles were your jaw connected to the skull. And this made it focus more on their molars and premolars for chewing. And they had these flaring cheeks so they actually had space for all these muscles, for all these strong muscles, and their dental enamel was about 4 times as large as ours. But what I find more interesting about this species is that their brain size and large separate from the Homo genus, showing that the brain might have been large, like, or the brain size might have been large actually multiple times throughout our history. Next species, Australopithecus sediba. It evolved 1.98 to 1.977 million years ago in southern Africa. They had a broader lower chest similar to humans. They have more pelvis. Their pelvis and femurs were also more similar to us Homo sapiens. They had a lot of facial features more similar to Homo genus. But at the same time, their arms and legs were more similar to the earlier Australopithecus, the late previous Australopithecus. I can't speak. Okay. The previous Australopithecus that we saw. So this is showing that they might have been a kind of a stepping stone that led to the Homo sapiens. Like this could have been well for possible common ancestors or possible ancestors. Then the Homo rudolfensis lived 1.9 to 1.8 million years ago in eastern Africa. Their brain case became large to about 775 cubic centimeters, I believe. They also had longer faces and larger molars and premolars. Then the Homo erectus, they lived 1.89 million years ago to 1100,000 years ago. They live in Africa and East Asia, so they're slightly moving out of Africa into Asia right now. Their growth was just similar to great apes, but they had shorter arms and longer legs compared to their torso. This is more similar to humans because apes before they had longer arms and like longer legs, but now their arms are starting to get shorter. Along with this, they also were a little bit stockier because they moved upward, right? So they're living in a slightly colder environment, so that helped them that. The Paranthropus robustus lived 1.8 to 1.2 million years ago in southern Africa. They had larger cheekbones, which allowed them to have larger chewing muscles to eat more tough and fibrous foods. The Homo heidelbergensis lived 700,000 to 200,000 years ago in Europe, Asia, and potentially also in Asia. They had larger brain cases and flatter faces, and they were first living in much colder climates. So they had a much stockier bodies. They also started using fire at this time, so which really helped them during the colder climates. And also, their brain size at this time was really starting to enlarge a lot, so they're able to start making shelters, use spears, and use that to help them survive. Then Homo floresiensis lived 100,000 to 50,000 years ago in Asia, specifically Island of Flores, Indonesia is where they were found. These people were actually really small. They were 3 feet and 6 inches tall. So it's thought that like gene fixation occurred that made them so small, but some scientists think that they were small before they reached the Island of Flores. Then finally, we reached the Homo neanderthalis, or as we more commonly know Neanderthals. They lived from 400,000 to 40,000 years ago in Europe to southwestern to Central Asia. They had a larger middle face, more angled cheekbones. They also had shorter and more stockier bodies and huge noses. Those helped them during the colder areas that they were like before we were all in Africa. Those much warmer. Their brains are actually more Homo sapiens sized, and they ate seasonally whatever they found in the area. Like they were seasonally eat whatever food was there, even if it changed. They also started using they started using more sophisticated tools. Like for example, they started using like bone needles. So that helped them make more clothing. They also started being a lot more sophisticated and said they had graves and more ornamented objects. So it's unknown how they exactly went extinct, but it's thought that when us Homo sapiens started going into Europe, we started taking over the more preferable hunting grounds. So then that kind of led towards their extinction. But there's also some interbreeding that happened between the Homo neanderthalensis and us Homo sapiens. So finally, we reached the Homo sapiens. We came 300,000 years ago and we're up now into the present. So we evolved in Africa. We also have a lighter skeletal builds and like a lot smaller brow ridges. Our brain tires are 3 times as large as chimpanzees, about 1,300 cubic centimeters. We also have a lot less developed teeth, and we started making more specialized tools. And about 1,200,000 years ago, we started farming. And if you want to know more about Homo sapiens, just like read your history textbooks. I don't know anymore. So now I want to talk about like some cool adaptations that I found in the Homo sapiens. So first, when I started researching this, I was thinking like, why did we evolve to have like such bigger brains? So what actually happened is that it's a mix of multiple factors, environmental, social, and cultural factors. Environmental factors like where are the best place to hunt and like how to hunt. Social factors like predicting what your predator or prey can do and how what other people react. And cultural factors like you gathering all this knowledge and like passing it on to others. So so all these factors mix in like a certain way, along with there's a lot of climate change that are happening at this time, which probably led to us having these larger brains. But at the same time, these larger brains also take 20% of the energy in the body. So that's kind of why we're like stickmen compared to all the other organisms that we see. Like, for example, gorillas, they're much more muscular than us. So to overcome this, we started digesting food a lot faster. And then, so now we're just basically stick figures. But we're a lot more smarter than other animals. And at the same time, for example, like when we're walking, we have our pelvic bones start getting a little smaller to help us a little lower, so we're actually able to walk more efficiently. But at the same time, we couldn't get too small, so the babies can actually exit the birth canal. So to overcome this, babies actually start having more premature birth. So that's kind of why both of these babies, for example, they can start walking in the first few minutes, but we take a very long time before we can do that. So then we also have our longer legs and us having basically no fur and a lot of sweat glands that allow us to have longer endurance than any other organism that they were. And the final good amazing adaptation that I found is that we're the I think the only species that actually have a menopause, which basically when ovulation periods basically stop. So this kind of is thought to have occurred because the grandmothers were taking care of their grandchildren more, so then the mothers of the child will have more time to actually spend doing other stuff like they're in their prime that time, so they're more fit, so they can do other activities, get more children. So that was overall beneficial for passing on their genes. So we have more of a menopause during when we're like 40 to 50, 50 years old, so more the later time. And that's my presentation. Thank you guys for listening.